Bismillahirrahmanirrahim. We're looking at network address translation. Now, quickly explaining why we need this concept. The internet, when it was created, the IP address given was 32 bits in size, and we've seen the address space, which is 4 billion and millions of IP addresses. Initially, it was thought that this number would be more than sufficient. However, we've seen now that there's been an explosion in the number of devices that we use, and we have actually used up all the IP addresses. So now, to make sure that we still have IP addresses available, the internet standards have come up with a way of dealing with it. What they say is they speak about network address translation. So in this case, the technology allows a site to use a set of private addresses for internal communication and a few global addresses for communicating with the outside world. What do we mean by this? This is our organization, okay? This is our organization, and we have machines inside it, and they're all connected through the gateway router to the internet. Okay? Now, these machines inside the network, they will have a private address. So in this case, we're using 172.18.3.1. We could also use 192.168, 1.2, 1.3, whatever. Okay? But you remember the private addresses that we spoke about here? These private addresses? It is from these addresses that we're going to allocate the addresses to our devices inside our organization, okay? So within the organization, they're going to have a private address. So when they communicate with one another, okay, they make use of these private addresses. But when they go outside on the internet, they make use of a global address. All these devices, when they send the packet outside, at this point, they will take a global address and then go out on the internet. Because when anyone is sending anything from the internet, they don't need to know where exactly within the point, the destination lies. For the rest of the internet, they only need to know that this is where the packet has to come. And then at this point, the router then knows where exactly to send it. And we will see in a moment how the router does that. Okay, so you have to understand for network address translation, you have a set of private addresses that are being used within the organization, and you have a small number, maybe one, maybe two, okay, but a small number of universal addresses, so that anytime a packet goes out from the internal to the external, it will take on a universal address and go out. The example I gave for this was the ID that we use. Okay, so while we are within the country, we have an ID card with a given ID number, right? And we don't need to carry around our passport with us if we are within the country. We don't need to carry the passport with us. However, once we go outside the country, we cannot use our ID card anymore. We have to use the passport. Okay, and the passport in this case is globally recognized based on your nationality. So are you American? Are you Saudi? Are you British? what is your nationality? It's recognized by the passport that you use. You could have an ID, a local ID for the country, and your ID number could actually be the same as an ID number for someone living in, let's say, Brazil. Okay, maybe your ID number matches with another person living in Brazil. But does it matter? No, because your ID is specific to your country and the other person's ID is specific to Brazil. However, both of you will have different passports and you'll have different passport numbers when you go out of your respective countries. Okay, so this is the whole concept of network address translation. While you're within the organization, you can use private addresses, but when you go outside, you have to use a universal address. So this diagram is explaining it. Again, we have on the left-hand side, we have the private addresses. We have one global address, 200.24.5.8. The packet is now going out, and the source address, because it's inside the network, the source address is a private address, 172.18.3.1. But when it exits the network, it's going to take the universal address, 200.24.5.8. Similarly, when a response comes back, the destination address is 200.24.5.8. But when it reaches the router will now assign the private address so that it goes off to the right device within the network. Okay, so this is network address translation. Now, how do we actually go about doing it? Let's see with the help of this example. So we have I'm just trying to see if I can actually add comments in there. Unfortunately, it doesn't seem like I can do that. So I will have to just explain it to you verbally. Actually, let's do it in here itself. I'm going to zoom this in further. Yeah, so we can see it clearly. Yes. Okay, so now we have in here the first step. You're having a packet coming in from the private network. The source is 172.18.3.1, private address. Destination is any address on the internet. When it comes to the router will now create an entry, okay? And it'll say 172.18.3.1 is sending a packet to the universal address 25.8.2.10. And then what will it do? It will take out this private address and replace it with the universal address and send it out. Now a response is coming back from 25.8.2.10, okay? The destination. The destination is now responding. The destination will use the universal address for responding, 224.8.5. When the packet comes into the router will use the translation table and it will see, it's 25 and it corresponds to 172. So based on that, it will remove the 200 address, the universal address, and replace it with a private address. And in this way, the packet will be delivered to the internal device. Now, because we could have more than one device communicating with the same destination, for example, it could be that 25.8.2.10 is the IP address for, let's say, the MSN website. Now you could have many users communicating with the MSN website at any given time. So they would all have their address and the same destination address. So now how does the router know on the way back? How does the router know which one of these packets is for which devices? So to avoid confusion, we make a combination of the private address and port number. So you could have two devices, in this case 3.1 and 3.2. They're both communicating with the same external address, 2583.2. But in this case, both of them have got different port numbers. So on the way back, your router will look not only at the destination address, the router will look not only at the source address in this case, right? Because we're looking at the source in here. The source, sorry, this is the source, okay? So we're not only looking at the source address, but we are also looking at the port number. So in this way, we can easily have more than one connection being established by more than one device to the same destination. And we can still carry on with translation without any confusion. So this was about network address translation.